Surprise! Mr. Springer here. I'm doing lesson 3.8. The gremlins have gotten into Miss Goobrood's computer and it's not working again. So I have to help her out a little bit here. So please bear with me. Also, feel free to chat with me or Miss Goobrood if you need any help with this lesson. So in lesson 3.8, you are still working on the target. I can recognize multiplication links by adding, subtracting, multiplying, and comparing fractions to solve word problems. So we're putting all of the operations that you know together and seeing how they're similar and different. All right. So first of all, we will be on page 105 of your student activity book. So if you want to look at that or have that handy, if you have the book, that's great. If not, if you have it online, have that open so you can take a look at that as well. First of all, let's think. For which operations do you need to find common denominators? When I say operations, I mean adding, subtracting, comparing, or multiplying. So when you have some fractions, if you have to add them, you had to subtract them, you had to compare them, and you had to multiply those two fractions together, which ones would you need common denominators? Let's see if you're right. For comparing, adding, and subtracting. Well, of course, adding and subtracting. Comparing, sometimes we do. All right. There are other ways using your benchmarks and things like that for comparing fractions, but you can always compare fractions by getting a common denominator. Once you get a common denominator, all you have to do is compare your numerators because your unit fraction is the same size. So next, for which operation do you need to know which fraction is greater? So which ones, adding, subtracting, comparing, multiplying, which ones do we have to know which is greater? I bet this one was pretty easy because just like whole numbers, the only one we have to know the order is subtraction. We want to start with the greater number when we subtract. Which of the operations gives a greater result than the starting number? So after you've added, subtracted, compared, or multiplied, will you get something greater? All right. Well, just like whole numbers, adding gives us a greater. None of the others, though, do. When we multiply whole numbers, we get something greater. 3 multiplied by 5, 15. 15 is greater than 3 or 5, isn't it? But when we multiply fractions, we don't get something greater. 1/3 multiplied by 1/5 is only 1/15. That's less than them. Which of the operations gives a lesser result than the starting number? I kind of told you that a second ago, but also subtraction, right? Subtraction and multiplying. Yes, subtraction because you're taking away from the starting fraction, so it's going to get less. And multiplying because you're taking a fraction of it. You're taking less than a whole part of it. All right. Now, so after reviewing and talking about that, pause the video and work on completing the fraction boxes on page 105. Here is a fraction box. They show you here, so take a look at it. Here's showing how you comparing fractions, adding fractions, subtracting fractions, multiplying the two fractions, 1/3 and 1/6. So you're going to do the same in number 1. You are going to compare these 2/5 and 7/10, add them together, subtract them from each other, and multiply them. Then do the same for this one. After you're done, unpause the video and I'll go over them. Welcome back. All right. So in fraction box 1, comparing 2/5 and 7/10. Well, you're going to have to bear with me because as I do this, I have to use the pen and it doesn't work very well using my mouse pad. All right. But 2/5 compared to 7/10. I would think use benchmarks of a half. 2/5 is less than a half because half of 5 is 2 1/2. So 2 is less than 2 1/2. So that is less than a half. 7/10 is greater than a half because half of 10 is 5. So if 2/5 is less than half, 7/10 is greater than half, 2/5 is less than 7/10. So bear with me as I write that. 2/5 less than 7/10. Now, as I was saying a moment ago, though, one thing we can do is you can always use common denominators to compare fractions. Let's see, is 5 a factor of 10? It is. 5 multiplied by 2 is 10. So if I multiply 5 by 2, I have to multiply my numerator by 2, so I'm multiplying by 1. So 2/5 is equal to 4/10. How does 4/10 compare to 7/10? Ah, Mr. Springer, that is easy. All I do is look at my numerators. Because my unit fraction is tenths, having 4 of them is less than having 7 of them. So I was right when I said less than. Now, adding. I have to use my common denominator, my equivalent fractions with common denominators to add. So I'm going to take my 4/10 and add 7/10. And when I do so, because I have common denominators, all I'm doing is adding the numerators. 4 plus 7 are 11. And the size of my pieces are tenths. That doesn't change. Oh, I noticed my numerator is greater than my denominator, so I can take a whole out. When I take one whole out, I grouped 10 of the tenths to make 1, and I still had 1/10 left. Subtracting, I also need to use common denominators, but as we talked about earlier, I want to use the greater fraction and subtract the lesser fraction from it, because I don't want to go into the negatives. I'm finding the difference between them, and I subtract numerators because the size pieces are the same. If I have 7/10 and I take away 4/10, that's 7 subtract 4 are 3. Just like if I had 7 apples and I took away 4 apples, I would have 3 apples. I have 3/10 left. Multiplying. I can use the simplified versions of the fractions. I don't need the common denominator ones. So I can take the 2/5 and multiply by 7/10. Another nice thing I can do when I'm multiplying is I can simplify first. I can see that, hey, 2 and 10 have the same factor of 2. 2 divided by 2 is 1. 10 divided by 2 is 5. So I factored out 2 halves or a whole. So it didn't change the value any. Now I multiply numerators. I'm taking 1/5 of 7/5. 1 multiplied by 7 is 7. 5 multiplied by 5 is 25. 7/25. And that makes sense that I would have less because I was only taking 7/10 of 2/5 or 2/5 of 7/10. One of the two, it doesn't matter. So I get less. 3/5 and 4/7. First comparing. 3/5, well, I remember 2/5 is half, so 3/5 is greater than half. 4/7, well, 3.5/7 is half, so they're both greater than a half. So I can't compare using my benchmarks. So I'm going to use common denominators. 5 is not a factor of 7. 5 and 7 only have a common factor of 1. So I'm just going to use 5 multiplied by 7, I'm going to use 35 for my common denominator. So 5 multiplied by 7 is 35. 3 multiplied by 7 would have been 21. So 3/5 equals 21/35 compared to 4/7. Well, 7 multiplied by 5 is 35. So 4 multiplied by 5 is 20. All right. Now I can compare numerators because my unit size are 35ths. 21/35 is greater than having 20/35. All right. A lot of work to compare them, but I need them to have the same denominator to add them anyway. So I'm going to use the fractions with common denominators, 21/35 plus 20/35. So I have the same unit fraction, 35ths. I have 21 of them, plus 20 more of them would be 41 of them, or 41/35. Ding, ding, ding. I notice I have a fraction greater than 1. I can group 35 of the 35ths to make a whole. And when I take those 35/35 to make a whole away from the 41 I had, I have 6 left, and they're still the size 35ths. Notice my denominator was 35, 35, 35, 35. I never changed the size of my pieces. Subtracting, I'm going to use my greater fraction first, and I'm going to use the common denominator ones. Let me change my pen color for us. So really could do it mental math, but I won't. 21/35. If I take away or subtract 20 of them, I only have one of those 35ths left. Remember, subtracting is finding the difference. The difference between having 21/35 and having 20/35 would be 1/35. So that's why sometimes we'll say how many more. Finally, multiplying. Multiplying, I can use the simplified versions. It doesn't matter what order I write them in, because order doesn't matter in multiplication, only in subtraction. Now, can I simplify first? 3 and 7 have no common factors. 5 and 1, well, I shouldn't say no. They only have 1 as a common factor. So I can't take any common factors out. So 3/5 of 4/7. 3 multiplied by 4 is 12. 5 multiplied by 7 is 35. So if I took 3/5 of 4/7, that would be taking 12/35. Makes sense? 12/35 is less than 20/35. I'm only taking 3/5 of them. I'm not taking all 5/5 of them or more than all of them. All right, so let's move on. Now, how are the operations of adding, subtracting, and comparing fractions similar? So how are adding, subtracting, and comparing fractions similar? What were the things that they were similar about? Let's see. Adding and subtracting required that the fractions are made up of the same unit fraction. So they had to have a common denominator, is what that's saying. Fractions can sometimes be compared using different methods, but we can always be determined by renaming them with the same denominator. So remember the first one, I was able to use benchmarks, but I could also use common denominators. The second one, I have to use common denominators. So you can do different ways of comparing, but if you get common denominators, that always works. How is multiplying fractions different than the above operations? So how is multiplying fractions different than adding, subtracting, multiplying, or comparing them? Okay, some things you should have mentioned was fractions don't need to have the same denominator. We can use them just the way they are. Multiplying fractions means taking a piece of a piece. We're not combining them like adding. We're not taking away or comparing them like subtraction or comparing how different they are. We are taking a piece of them. When you multiply fractions, you're taking a piece, less than a whole of it. In multiplying fractions, the denominator does change, and that's different than in adding and subtracting or comparing. And finally, the other thing with multiplying fractions is you can simplify them before you multiply. If sometimes you can factor things out before you multiply. All right, continuing on this page, we have Dear Puzzle Penguin. Dear math students, one of my friends said that he would give half of his sandwich to me and half of his sandwich to my sister. My sister said, but then you won't have any left for yourself. This doesn't make sense to me. I know that half plus a half is 2/4. My friend should have plenty for himself. Did I do something wrong? What do you think? Okay, so go ahead and think about this. Draw a diagram if you need to. See what you think. And write down your response and then unpause the video and see mine. Welcome back. So you should have your answer figured out before I show you mine. So I'm kind of one that really likes to draw a diagram. So as I think about this, if he says he has a sandwich and he's going to give half to Puzzle Penguin and half to his sister, the sister said he wouldn't have any left, and that's right. Puzzle Penguin said half plus a half should be 2/4. Well, wait a minute. Half plus a half shouldn't be 2/4. A half plus another half equals the whole thing, which would be 2/2. I see. Puzzle Penguin changed his denominator. So how would I write this? I saved some time and I typed it up ahead of time. The two fractions have common denominators. To add them, you add the numerators, 1 plus 1, and keep the denominators the same, 2. 1 half plus a half is 2/2, which equals 1 whole sandwich. All right. So going on, we have some word problems with mixed operations. Pause the video and complete page 106. What you might want to do is do problem 4, then play it, and then pause it and do number 5 and play it and pause it. Or you can do the whole page and then watch mine. All right, good luck. Welcome back. Let's take a look at first number 4. And it says, yesterday, Mr. Swenson made 2 3/4 quarts of strawberry jam and 1 1/8 quarts of raspberry jam. How much more jam did he make than how much more strawberry jam did he make than raspberry? Okay, so I know that 2 3/4 quarts of strawberry jam is greater than 1 1/8 quarts of raspberry jam. I need to figure out how much more he made. So I'm not comparing. I already know this is more. I need to subtract. So I'm going to be subtracting 2. Whoa, let's make that a little smaller there, Mr. Springer. 2 3/4 is the greater number, so I'm going to start with that. And then make it smaller. And I'm going to subtract the lesser amount, 1 1/8. Now, as I see this, I do not have common denominators, so I'm going to get common denominators. All right. And 4 is a factor of 8, so I can change my fourths into eighths by multiplying 4 by 2. If my pieces get 2 times smaller, I need twice as many to still have an equal sized amount. Don't forget to keep your whole number. That's a common mistake I used to make. 3 multiplied by 2 is 6. 4 multiplied by 2 is 8. 3/4 are 6/8. I remember that. I've done it a million times, it seems like. I get to keep 1/8, 1/8. And now I can just subtract out. 2 6/8, taking away 1/8 would be 5/8 left. Take away a whole is 1 5/8. Now, it's kind of hard for me to do, but if I had done this on paper, which actually I did ahead of time because that's being responsible, is I would have drawn a diagram. I would have drawn out 2 3/4. I would have crossed out a whole. I would have changed my 3/4 into eighths and crossed out one of the eighths and seen that I had 1 5/8 left. So now in my answer spot, I would put 1 5/8 quarts. Today, number 5. Today, Mr. Swenson is making 2/5 quarts of grape jelly. He will give half of this amount to his neighbor. How much jelly will the neighbor get? All right. I'm going to draw a diagram because this one's got me a little confused. He's making 2/5 quarts of grape jelly. So if I draw a whole quart, oops, I'm going to redo that. If I draw an entire quart or a bar for an entire quart and partition it into fifths, and shade in 2. So that's how much he made. He made 2/5 of a quart. He's going to give half of this amount to his neighbor. Well, half of it is this much. I'm taking part of this part of a quart. I'm taking 1 part, and it takes 1, 2, 3, 4, 5 parts to make the whole. What operation did I do? I multiplied. I took half of, fraction of means multiply, half of 2/5. I know some students don't like to, but my favorite thing is to factor first. 1 and 5, only factors, common factors they have is 1. 2 and 2 both have 2 as a common factor. There's 1, 2, and 2. There's 1, 2, and 2. Now when I multiply numerators. 1 multiplied by 1 is 1. And multiply denominators. 1 multiplied by 5 is 5. 1/5 is correct. And my diagram shows that. 1/5 of a quart. Whenever, especially multiplying fractions, you have to remember what was my whole. My whole is 1 quart. Number 6, Mr. Swenson is also making 2 1/6 quarts of cherry jelly and 3 1/2 quarts of orange jelly, or 3 1/12. 3 1/12 is greater, so he's making more orange jelly. He will mix the two kinds together. How much of the mixed jelly will he have? Well, if I mix them together, I'm going to have this much plus this much, so I know I'm adding. 2 1/6. And I'm adding 3 1/12. Okay, so I do not have the same size pieces, so I need to get common denominators. But 6 is a factor of 12, so that makes it easier. Don't forget my whole number. 6 multiplied by 2 gives me 12s. My pieces just got twice as small, 2 times smaller, so I need 2 times more pieces. 1/6 becomes 2 12s. Now I can add my 3 and 1/12. And as I do that, 2 plus 3 gave me 5 wholes. My 2 12s plus 1 more 12 gives me 3 12s. I notice 3 and 12 have a common factor of 3. So that means I can divide by 1 in the form of 3/3. And I'm just dividing the fraction to keep it equivalent. So I still have 5 wholes, but 3 12ths, 3 divided by 3 would be 1/4. Quarts. All right. Number 7. Yesterday, Mr. Swenson made 7/10 quarts of blueberry jam. His family ate 1/10 of it. How much of the blueberry jam is left? Now, when I did this in paper, I drew my diagram, and it really made this one super easy. So I'm going to show you my diagram. All right. Partitioning it into tenths. Anytime I have an even number denominator, I partition them in half. Now, half of 10 is 5, so I need 5 on each side. So that's going to cut it 4 times. 1, 2, 3, 4 gives me on this side, 5 on this side, and 1, 2, 3, 4 gives me 5 on this side, gives me tenths. And I have 7 of them. 1, 2, 3, 4, 5, 6, 7 of them. If his family ate 1 of the tenths, I have 1, 2, 3, 4, 5, 6 tenths left. And I notice that 6 tenths can then be put into groups of 2. 6 tenths would be 1, 2, 3. And how many of those groups of 2 does it take to make a whole? 4, 5, 3/5. Let's see it using our operations. I had 7 tenths to start. They ate 1 of the tenths. My size pieces never changed when I took that one away, so they only had 1 less, which would be 6. The sizes were still tenths. Then I noticed 6 and 10 have a common factor of 2. I put them into groups of 2, divide them in how many 2s did I have, and I got 3/5. Fractions aren't super bad. They're just a lot of steps to them. I ended up having 3/5 of a quart. left. Actually, quart I think is QT, to be honest with you. All right, suppose Mr. Swenson has jars that hold 5/6 of a quart, jars that hold 3/4 of a quart, and jars that hold 2/3 of a quart. Which size holds the most? Which size holds the least? How do you know? Now, like I said, on paper, I drew diagrams, but they were so close that I didn't trust my diagrams to be accurate. So I decided I better do something other than my diagram to decide which held the most. Well, I noticed 5/6 is 1/6 from being a whole. 3/4 is 1/4 from being a whole. And 2/3 is 1/3 from being a whole. I remembered the larger the more pieces, the smaller they are. The smaller the fewer the pieces, the larger they are. So 6 are smaller than fourths. Fourths are smaller than thirds, and thirds are smaller. Fourths are smaller than thirds, and thirds are the largest ones. So 1/5, or 5/6 is 1/6 from being a whole. It's a little bit less than a whole. 3/4, a fourth is a little more than a sixth, so it's a little further from a whole. So 5/6 is greater than 3/4. 2/3, a third is even a little bit bigger than a fourth, so it's a little further from a whole or closer to 0. It's a little less. 2/3 a little less than 3/4, or 3/4 a little greater. So it told me that. Now, if you're a little confused by me saying that, imagine my head too. So I said, I'm pretty sure 5/6 is greater than 3/4, and 3/4 is greater than 2/3. So obviously 5/6 is the greatest one. But the only way to be sure is to get a common denominator. So I said, 3 is not a factor of 4, but it is a factor of 6. So I could compare these two. 2/3, make it into 6 would be 4/6. Awesome. 2/3 is less than, or 4/6 is less than 5/6, so 2/3 is less than 5/6. But 4 is not a factor of 6. Then I realized, wait a minute. They both have the same factor of 2. So they have a common multiple. 4, 8, 12. I can make 6 into 12s. And I can make 4s into 12s. And I know 3 multiplied by 4 is 12, so I could make thirds into 12s. So I decided, to be sure I'm correct, let's make them all into 12s. 6 multiplied by 2 is 12, so 5 multiplied by 2 is 10 12s. 5/6 is 10 12s. 4 multiplied by 3 is 12, so 3 multiplied by 3 is 9 12s. 3 multiplied by 4 is 12, so 2 multiplied by 4 is 8 12s. Now all I have to do is compare my numerators. Having 10 12s is greater than having 9 12s. Having 9 12s is greater than having 8 12s. I was correct. So now let's go back and look at our question. Which size holds the most? 10 12s is the greatest, so 5/6 quarts holds the most. Now, which size holds the least would be 8 12s, which would be 2/3 quarts. And then finally, I have to answer the third question. How do you know? And how do I know is? To be sure, what I did is I used equivalent fractions. Wow, that's a terrible E. I'm going to just abbreviate equivalent to save you guys some time. I use equivalent fractions with common denominators to compare. And I don't know if I should even write it, just say it. But I use equivalent fractions with common denominators. I'm just going to abbreviate. Common denominators to compare. There you go. One more and a check understanding. Mr. Swenson made 6 2/3 quarts of jam last weekend. This weekend he plans to make 1.5 times that much. How much jam will he make this weekend? All right, so I'm going to think about this. 1.5 times this much. Well, times is a word that people often use to talk about multiplying, don't they? He's going to make 1 time that much would be 6 2/3 and another half times as much. So I'm going to multiply. And I guess I didn't do this one on my paper. So I'm going to multiply. Now, there's a couple things I can do. He's doing 1.5 times as much, or 1.5 groups of 6 2/3. So one thing I could do is say, hey, 1 times 6 2/3 is pretty easy. That is 6 2/3. Plus, he's going to do another half times as much. So now I still have to find half as much, or half a group of 6 2/3. So I know that's less than 6 2/3. Now, I don't know what you've exactly done in the past because I skipped to this one, but I could break this one up. See how here I broke up 6 2/3, or 1.5 into 1. 1 times 6 2/3 is 6 2/3 plus a half. I can do the same here again in breaking up 6 2/3. I'm going to keep my 6 2/3 here, plus, and now multiply half times 6. Well, that's easy. That's 3, because half of 6 is 3. Half times 6 is 3. Plus, now I need to do my half multiplied by my 2/3, which is still pretty easy. Still keep my 6 2/3. Keep my plus 3. But now multiply a half times 2/3. So I'm taking half of 2/3. 1 and 3, only common factor is 1, but 2 and 2 have 2 as a common factor. There's 1, 2, and 2. There's 1, 2, and 2. Half of 2/3 would be 1 times 1, 1 of those thirds. Actually, I could have probably done that in my head, couldn't I? Now, add it all together. 6 2/3 plus 3 would be 6 plus 3 is 9 2/3. Plus 1 more third would be 9 and 3/3. Well, 3/3 is 1 whole. So 9 and 1 more whole would be 10 quarts. No wonder they were making 1.5 times as much. They wanted to make a total of 10 quarts. Now, I know some people really like to do is make fractions greater than 1 and just multiply. 1 whole times 2 would be 2 halves, plus 1 more half would be 3 halves. Multiplied by 6 wholes multiplied by 3 would be 18 thirds, plus 2 would be 20 thirds. And in this case, this isn't super hard. The only reason I'm not a big fan of it is because then I have to change them back when I'm done. 3 and 3 have the common factor of 3. There's 1, 3, and 3. There's 1, 3, and 3. 2 and 20 have the common factor of 2. There's 1, 2, and 2. There's 10 2's in 20. Now I've factored everything out. 1 multiplied by 10 are 10. 1 multiplied by 1 equals 1. 10 firsts, or 10 over 1, is 10 quarts. Either way, I get 10. So that was a pretty easy way, that one too. All right, the check for understanding. Kind of can get confusing because the only time you've seen a fraction box was in the beginning of today's lesson. Draw and complete a fraction box for 2/5 and 3/8. Circle the rows that require you to use a common denominator. So when they're talking about is draw that fraction box, I suggest you just do it and draw the boxes around it when you're done in your notebook. Go ahead and pause your paper, or pause the video and then start it again when you're ready to watch. When you're done. Welcome back. All right, comparing. Where's my pens? There it is. All right, so first thing is comparing. 2/5 and 3/8. Well, 2/5, half is 2.5 fifths. 3/8, half of 8 is 4, so they're both less than half, so I need to use common denominators. They only have 1 as a common factor, so I'm going to use the product of 5 and 8, 40, as my common denominator. So 2/5, I'm going to make 40ths by multiplying by 8/8. Gives me 2 times 8 is 16 40ths. Compared to 3/8. So I'm going to multiply it by 1 to keep a equivalent fraction in the form of 5/5, because 8 times 5 is 40. Gives me 15 40ths. And now I can compare. 16 40ths is greater than having 15 40ths. So my compare is greater than. Now adding, I'm going to use these common denominators. 16 40ths plus 15 40ths and I add numerators, 16 and 15. Well, 15 and 15 are 30, plus 1 is 31 40ths. For subtraction, I'm going to start with my greater one but use the common denominators. So I'm going to use the 16/40. And I had 16/40. I'm subtracting 15/40. So if I'm going to think of it as taking away, I had 16, I took away 15, I would have 1 left. Or if I'm thinking of it as a difference, the difference between having 16/40 and 15/40 would be 1/40. Multiplying. Multiplying, I don't need to use the common denominators. I can use the simplified versions. So I can have 2/5 multiplied by 3/8. I notice here that 2 and 8 have the same factor 2. There's 1 2 in 2. There's 4 2s in 8. Numerator, 1 multiplied by 3 is 3. 5 multiplied by denominators, 5 multiplied by 4 is 20, would be 3/20. And that's how I would complete that box. And that also completes the lesson for Unit 3, Lesson 8. Seeing how multiplying compares to doing the other operations. I don't need, draw and complete it. Circle the rows that required you to use common denominators. So I think I would just circle it like this. I needed common denominators to compare. I needed common denominators to add. I needed common denominators to divide. Looks like this lesson is really trying to show me is I need common denominators for these operations. When multiplying, I don't need to get common denominators. I'm going to tell you is this is the most frustrating thing as a teacher is I work super hard teaching students to add and subtract fractions and getting a common denominator. Then you throw in multiplying and you don't need a common denominator, and then they get confused again. So good luck. I hope you don't get confused with it.